So welcome back to another algorithm. So in this one, we'll be exploring our new and interesting one, Bellman-Ford algorithm. So welcome back to Code with Akia. Today we are exploring an essential algorithm for finding the shortest path in graphs that may contain negative edge weights. So basically the Bellman algorithm. Unlike Gestra algorithm, Bellman-Ford works with graphs where some edges might have negative weights, making it more versatile with specific scenario. So let's just dive into it so that you can understand how exactly it works. So by definition, Bellman-Ford's algorithm is the shortest path algorithm that works on graph with both positive and negative edge weights. Unlike Gestra, Bellman-Ford can handle graphs with negative edge cycle and detect whether cycle exists or not. So let me just give you the step-by-step process of how the Bellman-Ford algorithm actually works. So Bellman-Ford works by iterating over all edges of the graph multiple times, relaxing the edge, updating the shortest distance to the vertex each time. So the process is basically simple. Initialize the distance to the start node as 0 and all nodes as infinity. Relax all edges in the graph v minus 1 times, where v is the number of vertices. This means updating the shortest distance known to each vertex. After v minus 1 iteration checks all edges again. If you can still relax any edges, then a negative weight cycle exists. So before diving into the coding part, let's look at the pseudocode so that you can get an idea of how we're doing this stuff. So the pseudocode basically shows that the algorithm first relaxes all the edges v minus 1 times and then checks for the existence of negative weight cycle, right? You can just pause the video and can look at the pseudocode so that you can understand like how we are going to frame our code. So now let's just move on to the actual coding. All right. So first of all, we'll create a function calling it Bellman-Ford as always. Inside of that, we'll have three parameters or argument, whatever you call it: graph, v, and start, right? Okay, so step one will be initialization. So initializing distances from start node to all other nodes is infinity. We are going to start our distances start node 0 and all other nodes infinity, right? Now we're going to just say that distance start will be 0. The first value, the starting node, will be assigned as 0. Rest of them infinity. Then relax edges. Now we'll start to relax edges like v minus 1. For node in graph, for neighbor, weight in graph, node, if distances, node plus weight. Okay, that's not what we want. If distances of the node plus weight is smaller than distances of neighbor, then we are gonna assign the distances of node plus weight to distance of neighbor. That's what we're gonna do. Right. Kind of interesting, right? So there are, but if you were to put this into, let's just say, practical application, so Bellman-Ford algorithm is used in various real-world scenarios, like finding the shortest paths in the graph with negative weights. So this basically can be used in detecting negative weight cycles, which will be crucial in financial algorithms to avoid arbitrage, and even network routing protocols like RIP, routing in information protocols. You can even use it in that particular sense also. So there are multiple real world applications to it. Not too many, but there are. If you are going into networking and stuff, you have scope with it. But it's good to learn these kind of skills. possess these slight edges. It gives you slight edge to a tons of programming. Even if you know one or two algorithms more, if you go deep into like three or four algorithms above, it gives you an edge from thousands of programmers. Thousands of programmers. So let's just create an agency one. So this will be our graph, agency graph with edge weights. So we, as you can see, we have the negative weight cycles too. Right? So A, B, C, D, E will be our nodes. Inside them, we will have the edges, weights. Okay. Now let's just number of vertices. We have 5 vertices. A, B, C, D, E. And then our start node is A. And let's just print, let's say shortest node. And then the result will be Bellman Ford graph v start node. This will be the 3 arguments that we're going to pass. And once you pass it, print the results. That's it. And Python 26.py. And as you can see, it's perfectly working. All right. So that's the Bellman-Ford's algorithm. It's an excellent algorithm when you need to find out the shortest path in graphs with a negative weights. It also helps detect negative cycles. If you like the video, then give it a thumbs up. If you didn't like the video, give it a thumbs down. Subscribe for more content like this. See you in the next one.